Welcome to Optimized AI Conference. This is episode 1 of vLLM from Zero to Hero. Today, you'll get hands-on experience with the powerful inference engine used by IBM, TikTok, NVIDIA, building the skills to become an excellent AI engineer and opening doors to top-tier companies. What will we cover today? First, what is vLLM? And then how to install and run it. Third, how to submit your first pull request. Imagine that you are running a LOM seafood restaurant where your GPU is the kitchen, the blue space, and the memory is limited and very expensive. There are requests coming in. Each request can have a party of 1 person or 3 people. What does the traditional method like PyTorch do? It is a poor host that pre-allocate large tables, and those tables are fixed size. No matter whether your request is 1 person or 2 people, it will always allocate this fixed size table. What is the problem? Here are empty seats, which corresponds to memory waste. What is the innovation of vLLM? It breaks a contiguous memory, so a big chunk, into small blocks. Each person can now have their own tables. And if a party has a size of 3, each person can pull over their table and form a party of the original size. This reduces the memory waste, which is called internal fragmentation, and drastically improves the memory efficiency. What does this look technically? This is called page KB cache, the fundamental block of page attention. It is inspired by operating systems' memory paging, which gives each sequence a virtualized, contiguous view of its KV cache, while the physical blocks are scattered in the memory. So instead of storing a contiguous block for all of the sequence, we can now use smaller blocks with fine-grained division so that the previous memory's fragmentation will be reduced. Although each request still thinks that it has the whole memory space and its KV blocks are contiguous, but in the physical layer, their blocks can be scattered into different blocks. For example, the first request has its tokens scattered across 2 blocks, even though when request 1 uses it, it still thinks that all the KB cache are contiguous. So vLLM will do the heavy translation. Part 2. How to install and run vLLM. There are 3 steps. First, get a GPU with Ubuntu operating system, such as 04, and then we can start this server, and then go to our GitHub repo. Second is to install the dependencies, and third is to do a test run. Let's see it in action. Search vLLM project, click the GitHub, and then clone the code. If you want to contribute to it, first create a fork here, and then clone your own fork. Next, since we should run this on a Ubuntu server, we can rent any server with a GPU and then SSH into the server. Inside the server, let's clone the repo, cd into our folder, and then install the dependencies, create a virtual environment, and then source virtual environment. Let's pip install the package. The first flag is use compiled, so it will compile faster. If you only modify Python code, pass in this flag so that it won't take hours to compile. But if you need to modify the CUDA or C+ code, we should omit this flag and compile it from the start. Hit Enter. It will resolve the dependencies and install this as an editable package where if you make any changes, it will synchronously reflect in this package. The installation was successful. How to do a test run? We can use Python, examples, offline inference, and basic.python. Hit enter. This will start the engine. I downloaded the model of Facebook's OPT model and then ran a for prompt. Let us open the vLLM folder, find the basic file that we just ran, and examine how it works. First, we initialize a LLM model with this Facebook 125 million model. And then we call lm.generate with the prompts we specify. With just 2 simple steps, 2 lines of code, you can do a test run of the engine. Finally, how to contribute to open source. There are also 3 steps. First is how to find a good pull request. Second, how to write a pull request. And then how to submit a pull request. So step 1, where to find a good item to contribute to? Is it go to the pull request tab, or is it the issue tab? We should go to the issues because we need to start with a problem and then come up with a solution, which is a pull request. So among the K requests, how can we choose one? A good idea is to select those with the tag of good first issue. They are beginner friendly and helps you to understand the overarching architecture. Now you have decided upon an issue, how to start writing code. Should we clone the original repo, or should we fork it first? We should always create our own fork, which is our clone of the entire production code base. Then you can submit your code on your own branch and then merge it back to the production VLLM. And before submitting code, what is one important step to do? Run the test. How can we start the test? For vLLM, we can use the command line of PyTest and then pass in the test such as test attention backend in those test folders. This will show you if you passed all of the unit tests, and then if you passed, you can include this screenshot in your pull request so that reviewers can approve it faster. Step 3. Submitting a pull request. First, you should push it to your own branch. And secondly, you will push your branch to the main vLLM codebase by submitting a pull request. On GitHub, it will automatically pop up this button. You can click the green one on the right saying compare and pull request. Now you have mastered how to install vLLM, how it works, and how you can contribute to it. In our next lecture, we will talk about the different optimizations that we all make, such as batching, scheduling, and chant prefill, which will help you crack interviews but also master the hard knowledge. Thank you for watching.